Hello everybody. Delighted to be chairing this panel of experts in the area of AI and explainability in particular. But I'll let our illustrious panel introduce themselves in a minute. But I'm Adrian Joseph. I lead data and AI solutions across BT Group. I've done a number of things in the industry. I worked at Google previously in data science and analytics. But also at EY, leading data analytics and AI teams. And I also happen to have recently joined the AI Council, where I helped advise the government on how do we keep the UK at the forefront of AI thinking. So with that, let me ask maybe Zoe, start with you, if you could do a quick intro, and then we'll move around the rest of the panel, please.
Sure, thanks, Adrian. Well, for those who don't know me, I report to Adrian. I'm Zoe Webster. I'm AI director in his team. So I've got responsibility for looking at how we can harness AI most effectively within BT to generate value. So my background is in AI and computer science. I have a master's degree and a PhD in AI. For the start of my career, I was focused on developing and demonstrating cutting-edge AI algorithms in a range of different areas, including health, retail, security, etc. And actually, back in that day, 20 odd years ago, explainability was something I was really interested in and very keen on looking at. So after that, I was at Innovate UK, the UK government's innovation agency, for 13 years in various roles, leading innovation strategy for the UK across different areas. And then I joined BT back in November.
Thank you. Michael, why don't we move to you next, and then Detlef.
Hi, I'm Michael Nauck. I'm a professor of computer science, and I've been working in artificial intelligence for about 30 years now. I work at King's College London. I've been doing various different things there. Currently, I'm director of the UKRI Centre for Doctoral Training in Safe and Trusted Artificial Intelligence. And that's part of the government's £100 million investment in 1,000 new scientists and engineers in AI. So trying to drive forward things in that agenda at the moment.
Brilliant. Thank you, Michael. Detlef.
Yeah, hi, I'm Detlef Nauck. I'm leading the AI and data science research program for BT in our research labs out here in Industrial Park in Martlesham. My background is also computer science and AI. I started out as a university lecturer back in Germany and joined BT for about 20 years ago. Have been in BT research all that time and now running the AI research program.
Brilliant. So thank you all for this. So maybe we should start with a definition so that we're all at the same level of what does explainability actually mean in AI? And maybe, Michael, I could start with you.
So explainability is exactly what it says. The question is, why do we need to explain AI? And I think that's the really critical thing. Well, it turns out there are different kinds of AI, but it's typically used these days when we're talking about neural networks or deep learning, where what happens is you get some data, you throw it into the algorithm, you turn the handle, and you get out an answer, yes or no. Is this a cat, for example? And so the problem with that is that we don't know, although we know it's a cat, we don't know why we think it's a cat or how we've come to that particular view. We don't know why we might deny a loan to someone or why we might do different things. And so explainability is concerned with trying to be able to show how that decision has come about. And it's a complicated area because actually what's going on in that algorithm is really complex and it's not straightforward. It's not an easy thing to do. That's the basic idea.
Fine. So, I mean, you mentioned sort of, making decisions about loans and other things. And of course, we've seen, examples of where things have gone wrong. And unintended consequences, some of which could be about decisioning, but others could be around, for example, gender bias or racial bias. And there are a number of biases that creep in. One is about bias in the data, one is about bias in the algorithms potentially, and then a third area might be about bias in the individuals that are actually building these beautiful algorithms. And I know from the AI Council, SANA, only 1 in 10 data scientists in the UK are female. So Zoe, what are your thoughts on those comments, and how do we ensure that we minimize some of the risks that Michael has mentioned?
So I think one of the things to start off is saying that humans do have biases, and I think we're all aware of that. Some of them are conscious, some of them are unconscious. And I think using machines to help us with decision making or support decision making, in a way, can give us a way of understanding the reasoning behind decisions, or looking to make decisions that are free from bias, if that is at all possible. And that's an open question. So being able to explain something around the algorithm, or where the data's come from, or whatever it is that's led an algorithm to a decision, can make it more easier to understand where there might be potential biases. So having an understanding, and I think this really key point is, as you raised, that it's not just the algorithm itself, it's the data, and it's how that algorithm and its decision is deployed. And at any one point across that system, there could be a bias that creeps in. So having some form of explainability would be incredibly helpful if it allows us to spot bias and to eliminate it. So that's one really big advantage of having explainability.
So Detlef, why can't these algorithms just explain themselves? Why can't we architect this in that way?
Yeah, like Michael said, it's extremely difficult. So you have the idea that you can ask an AI system, why have you made this particular decision? Of course, the AI system doesn't know why it made this decision, because most AI systems just do pattern recognition, and they look for something in the input that is similar to something that they have seen before, and then the output that they produce is similar again to that. And they have no theory, and they have no concepts, and they have no words to describe what they're doing. So engineering something like this into an AI system is a really big challenge. The other aspect you could think about is that, why don't we build systems that we understand? So there's this kind of other notion of interpretability. So can we build an AI system where we know how it has been built, what sort of constituents it has, and can we see inside the box and understand, yeah, that's what's going on, instead of something that we typically describe as a black box, where we can observe what's going in and what's coming out, but we don't really understand what's going on inside the box.
Michael, come back to you, and who's doing interesting work in the space around architecting explainability into their products. And I know some of the big cloud providers, for example, are now building explainable AI components into their AI stack. But when you look at where we are on this journey, who do you see at the forefront of helping in this area, and what are they doing? You might be on mute, Michael. We can't hear you. Is it just me, or?
No, we can't hear him either, but he's not on mute.
Oh, you're not on mute.
Are you double muted, Michael?
All right. Can we try and fix Michael's connection? So maybe I'll come back to you on that question, Michael. Really keen to make sure.
Better.
That's better. Yes, we can hear you now. Yes.
So sorry, I just switched microphone there. So that's a really big question and a really difficult question. So there are a few things that are worth saying. First, there are different kinds of AI. So there are some things that are, some AI systems that are much more easily explainable than deep learning or neural networks. And those are symbolic systems, and they have a very real and valuable place in the wider field of artificial intelligence. And I think it's really important that we don't ignore those systems, because that's really very, the importance of that is really in relation to things like reasoning. Detlef talked about recognition, about pattern recognition, recognizing images and so on. And I think there's something really valuable about AI that does more than just recognition, that is able to reason about things when you have recognized them. So, and because those kinds of AI manipulate meaningful symbols, things that we can recognize. You might represent a chair
or a cat and recognize that as a symbol, it's much easier to reason about those things and to explain what goes on there. But really, you're talking about those kinds of AI systems where we're using things like deep learning, neural networks to do some of these really important and really valuable recognition tasks where we have had incredible success and where we've been able to build some really fantastic applications. And so to get to the answer to your question, actually, there are lots of people doing work on explainability all the time. There are some very strong methods that are being researched. So increasingly, people are trying to do more and more research into this space because it's recognized as being a critical barrier to the kinds of applications that we might put these kinds of AI techniques towards. So I gave the example earlier of a loan. And it's critical that when you're dealing with some kinds of applications, you need to be able to say how that decision has come about or why it is that you've recognized things. Zoe talked about bias, and again, it's really important that we're able to try to understand, why or how the bias comes into things by explaining things in relation to the data. So there's a whole range of techniques that are being used. Some techniques try to make a correspondence between the input and the output to understand not what the machinery is doing, but what the link is between one thing and the other. So what are the features of the input that give rise to you recognizing a cat, for example, in an image? So some techniques work in that way. And there are some techniques that actually are keen to try to do more than that. And then what they want to do is to be able to explain what the elements of the machinery that gave rise to the decision actually do. And these are different kinds of explanation. So it's a really hot topic in research. There are lots and lots of people doing work in this area in universities and in commercial organizations. Google, for example, people at Google have done some really powerful work that is getting very widespread traction on different kinds of things. But your question about providers is not something that I, as an academic, should be talking about in terms of the commercial products. I don't know enough about that. But it is a really hot topic, and there's an awful lot of work being done with some very real, valuable ways of trying to get explanations from what previously were simply black boxes, as Detlef talked about.
Yeah. And so if I could maybe come to you then, is there when we think about this, is there a difference between interpretability and explainability?
I think broadly speaking, I think sometimes they get mixed up. So some people use one for the other, but I think broadly speaking, the main difference is, whether you understand the mechanics of what's going on in the algorithm. So you understand how it has gone from the input through to the output versus having a more general understanding, not necessarily the mechanics, but understanding the relationship between the inputs and outputs. So you can kind of predict what's going to come out when you put an input in, but you don't know the details of the algorithm. So I think it's also worth explaining that different people may need different forms of explanation given a particular context. So Michael mentioned loans earlier. In that case, you've got the person seeking a loan, you've got the bank manager or some person at the bank, and you've got the developer as well. And those will probably need different explanations. The customer may or may not have an interest in why they've been accepted or rejected. And again, if they've been accepted, they may not care why they've been accepted. They might care more if they've been rejected. The bank manager might also want to understand a bit more about, because they may need to interpret that decision and actually take what the machine is telling him or her and then actually turn that into the end decision. So that person will want to know a bit about why that has been the case. And of course, a developer, if they're still engaged with this, will want to understand how they can improve their performance. Another kind of example, which I think really hits home, is in the healthcare setting. If you're diagnosing a disease, for example, you've got the clinician, you've got the patient, and again, potentially the developer. So we need to think about who might need to know the deepest bits of the algorithm and what's happening behind the scenes, and who might just want to know the basics, want to be comforted that there's no bias or comforted that they could trust that decision, and to move on from that and not care too much about what's under the bonnet.
No. So, there should be a conversation, by the way, so please feel free to jump in at any point. You've just made it much more complex for us. Thank you, Zoe. So, multiple stakeholders needing different, types of explanations. That's the reality of this, right? Michael, did you look like you might wanted to come in? Please come in at any point. Any of you, please. This should be an interaction, not me just quizzing.
So I think Zoe's absolutely right. The key thing that we have to remember is that this is about people. The reason that we want explanations is because we're users, right? We want to have confidence in these systems, and the kinds of confidence that we might need will vary depending on what we're trying to do with it. But the critical thing is this: the point of explainability, and the reason why we're having this conversation is that without humans having confidence in using these systems, that they won't do bad things, that the bias won't cause problems, that they won't give the wrong results, that actually we can have some confidence that the decisions are the right ones, that if I'm denied a loan, I'm denied a loan because perhaps my income isn't high enough and there's no confidence that I'll repay it, that we can trust that these decisions are the right ones. And the reason this is so critically important is that everything is complex now. There's so much data available, and you can kind of use that to come to all sorts of different conclusions. We have incredible power now available to us to do not just the things that we have been doing much better, but to create a whole new set of applications. If we don't have confidence and trust that these systems are doing what they should, so what they're supposed to do first of all, and secondly, they give the right kinds of outputs, the right kinds of answers and decisions, then the fact that we've got great power in this technology will be irrelevant because we simply won't use it. And so explanation is critical because of the people and for us to use those systems.
Yeah.
I was going to say,
sorry, go ahead, please.
So I was going to ask, this may be a question for Michael and Detlef as well, but I have a feeling that a lot of this has arisen because there has been so much investment and emphasis on deep learning of late, which are not inherently explainable, whereas the techniques that you mentioned before and some I kind of specialised in back in the day have almost been kind of forgotten in a way in some areas, and so we've lost that, and now we're working out how we can make what is not interpretable more interpretable. I just wonder whether that's something, whether if we'd gone down a different path, whether we'd have these questions being posed earlier or later.
Well, sorry, forgive me for answering instead of Detlef, but I think we did start to ask these questions with earlier techniques, but they weren't powerful enough. So while the questions were relevant, the power wasn't there. What's happened is that in the last 10 years or so, we've had greater data to power these algorithms, and we've had bigger machines and more powerful machines that allow us to do much more. And what that's led to is some really impressive things that we can do. So voice recognition, image recognition, all the things that we see in the media and the press, having Alexa and Siri and all that kind of stuff, that's powered by these deep learning neural networks, this particular kind of AI that does this pattern recognition. It's a really powerful thing to do. It's a really valuable thing to do, but it's limited. It's a particular kind of thing. It's a recognition task. And what we will see is that we will need to bring together these recognition techniques together with some reasoning techniques, the kind of stuff that you were talking about, Zoe, where they will work together to build more powerful and more valuable AI applications that we will need. And so I really do think this is not a new question, but it's one that's become really important because we just don't understand how these recognition techniques, these recognition algorithms work. One really important thing to say as well, I think, which is we should also be clear about where there is a problem with the AI algorithm, or where we need to understand something, and where we need to understand what we as people, as designers, are doing in terms of our decision making. So there have been a couple of recent examples where we've been concerned about different kinds of systems in the press, like the exams, the school exams question about how to classify the results. And actually, the issue there was not about the technology, it was about the decision making of the people that designed what the system should do. So the system functioned as it should. It was just that people came to a view that that was the way they should classify the results. They should determine what the results were.
I mean, I want to get Detlef in as well. Please go ahead, Detlef. But I just have one observation, and Zoe, you and I have talked about this before, me, Detlef, as well. I mean, I think the algorithms were unfairly blamed in the example that you just described, Michael, and maybe for the reasons that you just said, right? And even the Royal Statistical Society tried to provide guidance, which was not allowed. So I was thinking at one point maybe I should write a piece saying that stop blaming the algorithms. Actually, it's nothing to do with that. It's to do with the human decision that went behind that. But Detlef, please jump in. What are your thoughts?
Yeah, no, I agree with Zoe and Mikey. As the beginnings of explainability and interpretability were like back in the 80s and 90s, where people tried to understand what are the rules in an AI system that are used to do reasoning. So back then it was more about looking into the box, understanding the mechanics and the reasoning inside. And that has gone away a little bit. And sometimes I think that people in the AI domain, they like to find the easy way out, just throw data into a black box system, let it churn and come up with a solution, and not investing the mental elbow grease that you need in order to really construct a system and understand what's happening inside. But I can make the explainability domain even more complicated by asking, can we get systems to have some sort of self-awareness so that they understand what they can do and cannot do? So I'd rather have an AI system that tells me, sorry, I have no idea how I should handle this particular input. I've never seen anything like it. And instead of just giving me the closest answer that it can find in the data that it has learned from or whatever has been coded inside the AI system. So this kind of idea, we want to design something that we understand and that can maybe answer questions about itself. What are you? How have you been built? What do you know? What do you not know?
Sorry, go ahead, Zoe.
No, sorry. One thing I was thinking about earlier, which I think touches on that point, Detlef, is about background knowledge as well. So I think if we can get to a point where it's not just us getting an explanation, but we can explain back to the machine, actually, this bit of data you're looking at is less important than the other bit of data, or actually the answer you've just given me is not quite right, and being able to adjust. So I think there's the possibility for explanations back to the machine so it understands more about its context, as Detlef has just said.
So you want to make it even more complex than Detlef?
Yeah, making your job harder.
You also want us to explain things to machines, not just the algorithms explaining things that.
Why not?
Why not? I mean, why do we actually? I mean, we keep talking about use cases that are obvious, right? I mean, and of course, algorithms have been around for a very long time, but nobody worries or questions the explainability of their spam filter, for example, right? Or how X-rays work or scans work. So why are there particular use cases that we need to fixate on more around AI explainability, and other cases where we actually don't need to explain things and it becomes relevant? Are we trying to apply a blanket around explainability to everything that has to do with AI when we don't actually need to?
Yeah, I think that we don't need explainability where we use AI systems as tools for experts. So where you have a human in the loop system. Right? So if you have an XI system that looks at an X-ray image, it doesn't need to explain to me why it thinks there's maybe cancer in the X-ray system. It needs to indicate this to the clinician who is used to work with X-ray images. So, and in this sense, an AI system would be a sophisticated sensor that detects something, points an expert to it, who can then verify, yeah, that's correct or not correct. On the other hand, kind of almost trivial AI systems, like let's take a sat-nav in your car, right? It creates a route for you, and like 40 years ago, we would have said, this is AI. Today, this is completely normal to us. But when I'm driving around Cornwall, for example, I'm always being directed onto small single-lane roads and then stand in front of the massive truck that the farmer tries to get past me. And I would like to have my sat-nav tell me, yeah, this route is shorter. I believe you can drive national speed limit, but I know nothing about the size of the road. And so therefore don't trust me that much in this area because there are a lot of single lane roads. So this would be useful types of explainability almost for kind of daily use scenarios where people need to interact with these systems and want to understand how much they can trust them.
Yeah, I mean, I'm a bit of a satellite navigation nut, so I run Waze and I'll run Google Maps at the same time, as well as using the in-car one to figure out which is the best one, right? And but I completely understand that. I mean, but there are situations like in fraud detection, right? I mean, do we actually need to be able to explain? You know, do we as individuals need that explanation? We just want to know that it's made, you know, the right decision and created a flag, right? And Michael, sounds like you want to jump in. What do we always need to explain things?
Well, I mean, fraud detection is a really interesting case because you might want to identify where there are problems, but if you're going to take some legal action, then yes, you probably need to be able to explain what's been going on and how you found that. It's valuable evidence. I think Detlef's identified the critical point. We need to understand what the purpose of the system is and what we're trying to do with it. There are many instances where we don't care, we don't need to understand exactly how we've got to particular end results. So, you know, if a machine is understanding your words or is recognizing things, it may be because of the application. That's fine, right? So I don't need to understand how my personal assistant recognizes what I'm saying to it and why I'm asking particular questions. But if there is a consequence that is going to affect me in a very significant way, then of course that's really critical. But it's not just about how we understand the purpose of these applications. It's also about what the legal implications might be, or what the, even if not legal implications, what questions there might be around accountability, or perhaps even what societal implications there might be. The point about bias is there are very significant implications here, some of which are legal, of course, but some of which might not be so. And we surely want to build computer systems in general that are valuable to us and valuable to society. Increasingly, it seems to me that we shouldn't be thinking about machines and AI as replacing us, as doing things instead of us as people, but we should think about, I think Detlef referred to this as, you know, humans and computers working together, humans and AI working together. And whenever you have those kinds of interactions, actually it's crucial that there is some degree of understanding of what the other, human or machine, is doing. Right? That's what we do when we work together as people. We explain, why did you do that? What's going on? How? Why? And that allows us to function effectively. The same is true for humans and machines. Okay, we need to have, increasingly, we will need to have even informal explanations of what is going on, why things have come about, what particular conclusions there are, if we are to work together effectively. And my view is that that will increasingly be the norm for interesting, complex scenarios where we want to apply this technology.
Right. You mentioned sort of legal frameworks, and you know, of course, we've got GDPR. Legal is one dimension, of course, but then there's also, you know, ethical dimensions as well, right? So the can we and should we. Zoe or Detlef, any thoughts on building on Michael's point around, you know, the legal constructs and things that we need to think about there?
Well, I was going to touch on the ethical side just quickly, and that, you know, I do have a concern that, you know, it's the potential for developers making decisions about where explanations are required or not, and I don't think that's necessarily right. I think, you know, users need to be consulted, and users themselves may not know when they don't need an explanation. So you know, given what you said right at the start about, you know, there's a lack of diversity within the developer community in this space and a number of characteristics. And I think having that community determine when they should build in explanations and when they shouldn't does concern me. I think we need more of a dialogue there. And I think there's a time issue here, and some of what Michael was saying around, you know, we want to build machines that are good for society. I think, you know, we're all aware, I think, or lots of us are aware that, you know, we're getting AI-driven recommendations and search results when we put in queries, and actually some of those are, you know, giving us stuff that creates echo chambers or, you know, doesn't challenge us, and actually, you know, that may not have an impact in the here and now given a particular query, but over time that does. So I think we need to think about explanations in that context as well. So it's even more complicated.
Yeah.
And some of those recommendation engines, I mean, reputedly, or you know, apparently, about a third of Amazon's revenue comes from on the e-commerce side, from their recommendation algorithms. But we don't ask for explanations on those. Detlef, you look like you wanted to jump into.
There are a couple of interesting questions in the Q&A here. So people are asking.
Oh, sorry, I can't see those.
How do we know that we can trust an explanation that has been given to us by an AI system? And that's a really good question. So the trust usually happens, and probably Michael has to say more about this, but if the concepts that are used in explanations are relatable, right? So if you know that you're speaking the same language and you're going back to the same sort of experiences. And we might see a little bit like this, and you just mentioned recommendation systems. So if you look at things like Netflix or Prime, these video services, when they give you recommendations, sometimes they say, we recommend this one because you have watched that in the past. So they show you what they think is similar to the recommendation. So there's some form of explanation here that uses the concept of your interest in movies and tries to tie it back to what you have done in the past. But I mean, Michael is the expert on trust and safe AI. So I don't know what you think, Michael.
So I think it's a really hard question. The answer to that is really, really tough. Clearly, we need things like transparency. We need to understand what is going on, and explainability to understand how particular decisions have come about. I think it's really important. There are other aspects relating to the way in which we people relate to technology. So safety is another important aspect, which is we're talking about explaining the decisions of AI systems. I think that's really important, but we can also provide some degrees of assurance that the decisions that are being taken are the right ones, that a system is doing what it should be doing, that the behavior is as we expect it to be. And there are well-defined techniques for, in some cases, providing some guarantees that a system will do what it's supposed to do, or for monitoring it and for taking mitigating actions if it doesn't do what it should be doing. And so I think there are a number of different dimensions to this, some which are hardcore technical questions about how we can get assurance that a system is doing what it should do. And then some perhaps other things which relate to how we as people interact or relate to these systems, ensuring that we can have explanations, ensuring that those are transparent, ensuring that sometimes if the systems are unknown, that we can have the recommendations, I'll be careful about that word, but the recommendations of other people that is an appropriate system to use. But this fundamentally is about what we as people require to have confidence that we can use a system effectively, that it's not going to do bad things. And that's as much a technical question as a psychological question.
So there was a question here about transparency that I think you probably covered as well in your answer, Michael, and about being accidentally created into the code and programming. Zoe, was there something you wanted to add to that?
There were a few questions actually around the trustworthiness of the explanations themselves, and I think one was raised. I think we are expecting machines to be at a higher standard than people. We all give all sorts of explanations behind our decisions. Doesn't mean they're right, and doesn't mean they're not biased in some way. So I think we are holding up machines to a high standard, but perhaps that's not the wrong thing to do if we're going to be using them to impact on major decisions. But I think there is something around, there is the possibility of gaming explanations as well, and getting people to change their behavior by giving them explanations which may or may not reflect reality. So I'm very positive about AI, I'm very optimistic, but I think there are some challenges that we face going forward to make sure that we don't lose trust, because actually the explanations are not trustworthy themselves.
Yeah, I mean, the brain is probably the most opaque algorithm that we've got, isn't it? So that, so yes, I think you've touched on a number of questions here, Zoe. I'm just looking to see if the other dimensions, trust, communication issues. I think we've probably touched on that. At risk of getting very meta, how do we establish that an explanatory system is itself trustworthy? Yes. Any quick comments on that question from Jeremy?
Yeah,
I think it touches on. Sorry, go on, Detlef.
That's really tricky, right? So it's not only that you need to kind of trust the output of an AI system, which you might do by observing it over time and seeing where it gets things wrong. But that the explanation itself is trustworthy is also means you trust that it actually describes what's going on internally. And I think, Zoe, you said it right, the explanations that humans give us are not necessarily trustworthy because they might be made up or they have an agenda within them. Not sure that we are there yet in terms of AI explanations, but I don't know what you think, Zoe.
No, I'm not necessarily suggesting people are gaming it, but I think there is the possibility that could happen in future, and I think we just need to be aware of that going forward.
I'm just going to add one thing, which is to say that I think it's absolutely right that machines are held to a higher standard than humans. Certainly right now, we're at the cusp of something. We don't yet understand enough about this area, and we don't yet understand enough about the legal, societal implications. So GDPR is something that's come in quite recently, where there are some requirements that we should be able to explain the decision-making that takes place on personal data, for example. Perfectly reasonable, but we don't yet adequately understand how to interpret GDPR and what the consequences might be. So we're still finding our way with the very first significant piece of legislation that says something about what we must do here, right? So absolutely, we need to keep, certainly today, we need to keep the standard really high. If we're talking about autonomous vehicles, for example, right? It's absolutely right that the standard is higher than it would be with human drivers. Why? Because the danger, the potential danger of this technology is massive, and we're still finding our way. So absolutely right, yes, there should be a higher standard. It's really easy for us to talk to people and to understand what they do, ask them questions and get them to introspect. Can't do that easily with machines unless we build it in, unless we develop the techniques to allow that to happen. And that's why there is this great big concern with these issues. And that's why we need to have the higher standard. And that's why it's still going to be a while before we solve this problem adequately.
I mean, I'm really excited about what Tim Cook at Apple describes as self-driving cars as being the mother of all AI, right? Because the amount that's in there, and I'm really optimistic as well, because if a self-driving car has an accident, every other self-driving car learns from that. But if you or I have an accident, assuming we survive, we're probably the only ones. And so I also think that we're not in the think that we will get self-driving flying cars, as we've seen last week announced. Will happen before we get certainly level 5 driving cars on the roads, particularly in London or Paris. I know we're pretty much at time. Maybe just any final comment from
because my hair.
I don't know, any final comments in closing on how do we unlock the value, but do that really safely in 10 seconds, each of you.
Michael wanted to go first, I think.
Michael, 10 seconds.
Adrian, you gave me a cue. It's great that autonomous vehicles can learn from each other, but it's really dangerous that they learn from each other because we don't know exactly what they're learning. So beware of the danger still.
Thank you. Detlef, 10 seconds.
Okay, I think it's important now that we're going to an engineering best practice approach to AI, which considers explainability, ethical standards, legal standards, and not just kind of using this kind of let's quickly train something up approach.
And Zoe, 10 seconds.
Based on that, I was going to say this is not just a technical issue, this is a socio-technical issue. This is people and machines coming together, and we have to take those perspectives into account.